Okay. Did I start it? Okay. Alright, so it's recording. So what we just discussed was number 1, constant rate of change, a changing and a changing. So the two changing we could also call variable. With number 2, we talked about how Tyler's rate of change was not constant for the entire trip. For the first 2 hours, he went 50 miles an hour. That miles per hour represents the unit rate. C, did he stop? Yes, he stopped between the second and third hour. D, what was his rate of speed the last 2 hours? And you should have gotten 25 miles per hour. I added an E. So, since we know it wasn't a constant rate of change for the entire thing, it wasn't constant, what we're going to call it, instead of constant rate of change, we'll call it average rate of change. What was his average rate of change for the entire trip? Well, if we look up here at this point, it was supposed to be 150. So if we did the slope, or the rate of change here, and did 150 minus 0 over 5 minus 0, we get for the entire trip, he had an average rate of change, or an average speed of 30 miles per hour.
Wait, so basically just where the graph ends, you can just...
That's where the trip stops.
Yeah.
Boom, we're there. Yep.
And then you just calculate that to find the average speed?
Yes.
It works every time?
Yes. Now, when I talk about in here, average rate of change, obviously we're going to use average rate of change whenever our situation is not constant. Average rate of change. Okay, and I also kind of simplify this and call it AROC. AROC. Average rate of change. AROC. Okay, so when y'all see AROC, I'm talking about average rate of change. Alright, so let's look at our notes. It said let x1 f of x1 and x2 f of x2 be any 2 points on the graph. The average rate of change of the function from x1 to x2 is given by this formula. F of x2 minus f of x1 over x2 minus x1. That is the same as our slope formula. Y2 minus y1 over x2 minus x1. So, in this first example, find the average rate of change for this function from one point to the other. So, let's look at A. So, our function is f of x equals x cubed minus 3x. And we've got these 2 points, 2 and 0. So if we plug 2 into this function, what's 2 cubed? 8. 8 minus 2 times 3, so 8 minus 6 is 2. And if we plug in 0, 0 minus 0 is 0. And we found the average rate of change, so we would do 0 minus 2 over 0 minus 2. So we get our average, our AROC, is negative 2 divided by negative 2, which is positive 1.
Mathematics.
I took this equation and I plugged in 2. 2 cubed is 8 minus 2 times 3 is 6. So 8 minus 6 is 2. When I plug in 2, I evaluated the function for 2. When I plugged in 2, I got 2 cubed minus 3 times 2, which is 8 minus 6. So you plug in 2, you get out 2. When I plugged in 0, I got 0 cubed minus 3 times 0. 0 minus 0 is 0. So these were the 2 points I'm looking at. 2, 2, and 0, 0. So if I take those and plug them into my formula here, the change in the y's over the change in the x's, I get an average rate of change of positive 1.
Is that what the graph on the right is supposed to do?
Now, this graph on the right does represent this function. So could we use the graph instead?
Oh.
Sure. Where's the function at a value of 2? Let's see where that crosses, right here. Oh, totally missed. Let me shift that around, see if I can get it anywhere near. Whoa, shifting wrong thing, shifting wrong thing.
Wait, so the x1 and x2 is just the order you do it in?
Yeah.
Pretty close.
Alright, that's pretty close. So do you see this function has a value of 2 when x is 2? And this function crosses right here at 0. So could we just count from here to here? Isn't rise 1, 2? Run 1, 2? So if we did rise over run for our slope, up 2 over 2, 2 divided by 2 is 1. We did it plugging into the function and we got 1. We did it counting on our graph and got 1. Okay, I would like you to try part B. I want you to do it both ways. Plug it into the function, see what you get, verify by looking at your graph. Okay, everybody zone back in and try part B.
Would it be, what would you label that as, like something equals 1 or what?
The average rate of change equals 1.
So m equals 1?
Nope. The average rate of change.
Oh, A-rock equals 1.
A-rock. Just write A-rock. Tyler, have you already done B? Not yet. Go ahead.
Actually, I got negative 2 over 1.
That's right. That is the truth.
So it's negative 2 is our is run is 1. Works.
Bro. Your hair.
Okay, so we should have gotten negative 2 on this one. So when I plugged in 0, I still got out 0, 0. Well, I'd already done that. When I plugged in 1, I got 1 minus 3 is negative 2. So my other point was 1, negative 2. So when I do negative 2 minus 0 over 1 minus 0, I get negative 2 divided by 1, which is negative 2. Now, if I had just looked at the graph at rise over run, we should notice that here's my 0, there's my 1. To go from, let me erase this point now. To go from this point to this point, do you see I go down 2, right 1. So if I looked at it in terms of the graph, thinking rise over run, it was down 2, right 1, my slope is negative 2, did I get the same thing? Okay, so the average rate of change for this function over this interval is negative 2. The average rate of change for this function for this interval was positive 1. So for an interval from 0 to 2, our AROC was positive 1. Over an interval from 0 to 1, our average rate of change was negative 2. I got different numbers. It's not constant, is it? No. I look at the graph. The graph's not aligned, so that makes good sense. Yes, sir.
I don't get how you're testing. Like I was confused on how you're testing it on the graph. Like how where these go to get rise to.
Okay. Where is x 0? X is 0. It crosses right there. Where x is positive 1. Do you see? I even drew in this little vertical line.
Alright, so where the line is.
So, right, where does this vertical line, whoops, now I messed up my vertical line.
That's fine.
But where does that vertical line cross the graph? Right here. So that's how I found those 2 points to count my slope out on. Yes, ma'am?
Why do you have to do all that stuff when you do such a graph?
You don't. I just wanted to show you 2 methods and verify that they were the same. Yep. Okay, so on this one, find the rates of change for 3 different functions. So this is over an interval from 0 to 4. Now, could I have written this interval like this, from 0 to 4?
Yeah.
Yeah. From 0 to 4, what is the rate of change? So, let's see if you can figure out, I want you to see if you can figure out which graph is which. And I'm going to change these. I'm going to call the first one f of x, and then to make it easier for us to name, I'm going to call the second one g of x, and the last one h of x. That'll make it a little easier for us to name the functions once we get over here. Yes, sir.
I've answered it.
Okay. You don't have to do anything, do you? No.
That last one is really.
Yeah, I know the last one too. That's the one that's negative.
Okay.
And it starts at
When you
1.
start,
True.
if I plug in 0, what do I get at?
0.
On my second point, I plug in 4. If I plug in 4, what do I get at? Then with these 2 points, you do y2 minus y1 minus x2. Get up to 4, Alright, let's look at A. A is a line, isn't it? F of x equals 2x. That's linear. The average rate of change is actually constant. Any 2 points, any interval I pick on this line will have an average rate of change of 2 because the slope is 2. This is f of x, isn't it? A is f of x. If I count up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, up 8 over 4, that has a slope of positive 2. Okay? Part B, g of x equals the square root of x. So, if we evaluate this function at 0, if I plug in 0, what's the square root of 0? 0. If I plug in 4, what's the square root of 4? 2. Now I do y2 minus y1 over x2 minus x1. My average rate of change is 1/2. Okay, so for this one it was constant. But this one's not a line. All I can do is the average rate of change. So on this one, the average rate of change over this interval is 1/2. But if I picked a different interval, would I get out the same rate of change?
May not.
Probably not. So that is this one. Did you guys see? Up 2 over 4. What's up 2 over 4? 1/2. So this is B, g of x. So that leaves this one C, h of x. Now since we already know this one has to be C, let's just count it on the graph. From 0 to 4.
That's nothing.
Down 2, right 4. Down 2, right 4,
Negative 1.
negative 1/2.
Oh, that.
Let's do it by the equation now. If I plug in 0, this goes away, and I'm left with 2. If I plug in 4, 4 squared is 16. 1/8 of 16 is not hard.
2.
2.
Oh my god.
Okay, so it's the opposite of that, so it becomes negative 2 plus 2 is 0. So if I did 0 minus 2 over 4 minus 0, don't I get negative 2 over 4, which is
negative 1.
Okay, so is this one linear?
No.
No. So all I can do on this one, once again, is an average rate of change. These are actually not rates of change, but average rates of change for B and C. A actually is a constant rate of change because it's linear. Now, this asks us to try finding the average rates of change for these functions. So I could write this, f of x equals negative 5x plus 2 over this interval. This should be equals, guys, right there, equals. From 2 to 4. 2 to 4. All right. Somebody tell me, please don't do any work, Miss Wilby. Don't do any work. Why do I not have to do any work?
It's already in.
Because it's a line, so the average rate of change is just the slope. The AROC is negative 5.
Wait, what's comma x1 then? Does that just mean that that is x1?
These are the two from x1 to x2. See, it says from x1 to x2.
Oh, because they look like part of the equation.
Oh, okay. No, there should be a space right there.
Yeah.
Alright, so let's say you didn't notice that it was a line and you plugged in 2 and you got out negative 8. And then you plugged in 4 and you got out negative 18. So you did the average rate of change. So you did negative 18 minus the negative 8 over 4 minus 2. So you got negative 10 over 2, which is negative 5. Look there. The exact same thing, didn't I? So if you missed it and you did the work, you still should get it right. Now, this second one, f of x, is the square root of x minus 5 plus 1. And we're going to do this from an interval of 5 to 6. Now, this is not a line, so I can't take the shortcut out. But if I plug in 5, what do I get out? What is 5 minus 5?
0.
0. And 0 plus 1 is 1. If I plug in 6, 6 minus 5 is 1. The square root of 1 is 1. 1 plus 1 is 2. So to find the average rate of change, I would do 2 minus 1 over 6 minus 5. 1 over 1 equals 1. Now, if I picked a different interval, will this be the same on this one? No. On A, if I picked a different interval, will this be the same? Yes. Because this is linear, therefore it's a constant rate of change. No matter what interval I pick, it's negative 5. This is not linear. It's actually a square root function.
So it won't be a function because it's a square root.
Okay, I need all of y'all to stand up for a second and get your wiggles out. I've got about 25% of you full attention right now. That is nowhere near enough. Stand up and wiggle. Stand up, wiggle.
I can touch my hands.
Have to evaluate at 5. If you plug in 5, and we'll get it out. Plug in 5, get it out. That was a nice enough break. Alright. I expect full attention now. Alright, full attention.
I still have a question about the other one.
I know. I like
That's what it was. Oh, Lord, hold on.
All right, 3, 2, 1. You're back and quiet. Done. Yes.
Here, I forgot it.
All right. You can ask me later. All right. So Marilyn works at a beach ball making factory, and she pumps up beach balls. Her manager observed her one day and recorded the following information. We have time elapsed in minutes and the total number of beach balls that Marilyn was able to pump up during that amount of time. So if we look at this, from 0 to 10 minutes, she pumped up 30 balls. And then from 10 to 15 minutes, she went from 30 to only 40. So she kind of slowed down, didn't she? And then from 15 to 20 minutes, she went from 40 to, no change.
So she speeded up.
She checked her Instagram. Yeah, she did. And apparently there was a lot going on that day. Or Twitter, I'm not sure. Okay? And then she noticed that her boss was watching her, so she decided maybe I should do something. So from 20 to 30 minutes, she pumped up another 10 beach balls. So for the first 10 minutes that Marilyn worked, what was the average rate of change of her total number of beach balls that she pumped up?
3 over 1.
So it's going to be 30 divided by 10, which is 3 balls per minute.
But that
Okay.
was the bottom one.
What now?
This is like the bottom one, the meaning of this number.
We just write A-Rock equals 3, or do we have to write 3 balls a minute?
You have to write 3 balls per minute. If it's a word problem, it should have a unit rate.
Right.
If it's a word problem, it should have a unit rate.
Wrong.
Okay, so what does this mean? This means for the first 10 minutes that Marilyn worked, hey, can you stop?
Hey.
She did what?
She pumped up 3 balls a minute, 1 minute.
Yeah. She pumped up 3 balls each minute. Or every minute. Does that make sense?
Yeah.
Okay, B. What is the average rate of change of Marilyn's total number of beach balls pumped for the last 10 minutes that she worked? So how did this change?
Went from 10.
10, and how did this change?
10.
10, so 10 divided by 10 is? 1 ball per minute. Definitely a slower rate, isn't it? She went from 3 balls per minute, I guess that should be balls, to 1 ball per minute. Now, the last 15 minutes. So the change in time is 15, and the change in balls is 10. So 10 divided by 15 would say she only did 2/3 of a ball per minute for the last 15 minutes. Alright, so is her rate of change constant or changing?
Changing.
Changing. Or we could call it, what's the other word we could use there?
Variable.
Variable. Alright, so we can't say we have a constant rate of change over this entire time because we don't. But we could say we have an average rate of change. So for the entire 30 minutes, what was her average rate of change?
Let's see.
It's a blue number.
35.
55 by 30.
No,
5/3. 5/3 of a balls per minute.
Couldn't
So
that-
1 2/3 ball
Yeah.
per minute. Okay, that's for the entire thing. Now, based on the data, how would you describe the way she worked? You can describe it a lot of different ways.
I don't think
You might say that she worked really hard to start with. The first 10 minutes, she worked really hard. She may have worn herself out a little bit. And then she slowed down. And then she had to take a break because she was just tired. And then she finished a little better. Yes,
What kind of beach ball would you blow up?
it was a big one. Yeah, big.
I mean, don't say become inflated.
Yes, pump. Pump. Yeah. Alright, now last problem. The height, and I should have written in here in feet, that a shingle tossed from the top of the building can be modeled by this function. The height with respect to time is equal to -16 t² squared minus 5t plus 74, where t represents the number of seconds since the shingle was tossed. Now next year, you're actually going to create these equations. We're going to study quadratic functions, and we're going to deal with them in feet and in meters. So with feet, you're going to notice this negative 16 shows up a lot. Probably has something to do with gravity. And then this number right here is going to represent the initial velocity of the object. And then this number at the end will represent the height at which the object was thrown. So somebody's on top of a roof that's 74 feet tall right now, tossing off shingles.
Wow.
All right. But this year, we're just going to look at the average rate of change for that function. So we're doing it from 0 to 1 seconds. So you need to evaluate the function for 0 and evaluate the function at 1 second. Please plug those numbers in and evaluate the function.
We have to do the 1 to 0. That seems kind of not easy.
0 is really easy.
Yeah. Addition comes before subtraction, right? Yes.
Come together.
I ended up
Addition or subtraction from left to right.
negative 16. Oh, left to right. Okay.
So wait, is the equal negative 16, it's not a part of the equation, right?
All of that is part of the equation.
All of it's part of the equation?
Yeah. All right, so we plug in 0, guys, and anything with a variable goes away because we're multiplying it by 0. So I just get out 74. No work at all. Right?
Yes.
You plug in 1 for time, and you get negative 16 minus 5 plus 74. So negative 21 plus 74 is
53.
53. So we have these 2 points, 0, 74, and 1, 53. Now we can find the average rate of change. The average rate of change over that interval would be 53 minus 74 over 1 minus 0. So we get negative 21 over 1. So it's negative 21 feet per second. So during the first second, that shingle falls approximately 21 feet.
That's a lot of falling.
Yeah.
How heavy is the shingle?
Do you have to put like the negative, like
If you write it out in words, you could, but if you're just showing math like I did, you have to put negatives. All right. Now, from 1 to 2, we've already got 1. We got 1 is 53. Okay? If we plug in 2, we get out. Dun 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 dun. Anyone? 0. So my 2 points are 1, 53, and 2, 0. So I do 0 minus 53 over 2 minus 1. So we get negative 53 feet per second. So during the second second, didn't it fall a lot further?
Yeah. Almost.
Because gravity went.
There we go. The pull of gravity on the object increased the distance that the object fell. Awesome. Okay. Your homework is not that worksheet, obviously, because we just finished it. It's this worksheet I'm passing out now. So,
I think the last question should be homework.
we just answered it.
we did.
Oh.
Yes, we
I answered it out loud. You may not have written it down.
I love my house right now. We are going to like I think you have to cultivate.
Sounds like me,
Alright.